All right, here we go. Assuming that the graph of f of x lies above the x-axis, so when you look at this, we're talking above the x-axis, okay? On the interval a to what? B. So they're saying to the right of A, to the left of B, we will investigate the area bounded by the graph of f of x. Well, that's this right here. That's f of x, all of this, okay? The x-axis, well, I already showed you that, okay? And the lines x equals A, x equals B. These A and B are called the intervals. So you are supposed to get the area of the green region, right? Is there an easy formula for this? I mean, is that a rectangle? Is that a triangle? No. So this isn't so easy, but we're going to get it. And really, we're not going to get it. We're going to estimate the best we can. Okay? Sometimes we can use geometric formulas to find the area. Here's where you should start writing something. So if you were to get a rectangle, tell me the area of a rectangle.
Base times height.
Base height, okay. Base times height. Some people say length times width. Okay. What if you get a triangle?
Some people say length times height.
Say it again. 1/2, base times height, okay. What if you get a trapezoid? What's the area of a trapezoid? Okay, well, hang on. Trapezoid, two parallel lines, right? Like that. What do they call this? And this?
Base 1, base 2.
Base 1, base 2. Where's the height?
The
Perpendicular.
Perpendicular from there to there.
There.
Has to make a what? Right angle. Okay. So that's the height. Now does this help you? What's the area? 1/2 what? Times the two bases added together, you're right. And times? Height. Okay, good. So, finding area, if it's easy, triangles, rectangles, trapezoids, there's formulas for us to do it, okay. But you don't get a nice find the area of a triangle, except for the first couple slides. I made them super easy for you, I think. All right, so let's take a look at this one. All right, find the area of the area bounded by the graph y equals 2. And by the way, y equals 2 right here. You could say that this way, right? F of x equals 2. Okay, how do you graph f of x equals 2? Horizontal line right here. F of x equals 2 right here. There it is. So I want the area under that graph. Okay, but wait a minute. It says, and the x-axis. Oh, so you want the area between this and this. Okay. Where else? Yeah, on an interval between 1 and 5. So x equals 1 is right here. X equals 5 is right here. So what's the area I want? The yellow region. This is so easy.
4 times.
Area is going to be length times width. You're going to say what for your length? Starts at 1, goes to what? 5. So you're going to say what? 4 times the width. The width is 2. Okay, so it's 8. 8 square units. Okay, why is that so easy? It's a rectangle. Super easy, right? So if I give you a function that is a constant number, like 2, it forms a rectangle. It's going to be super easy for you. How many of these are on the test?
9.
None. Okay. So you're not going to get that. All right. Find the area under the graph of y equals 2x on the interval what? 0 to 4. Okay. So here we go. Apparently I didn't give you any graph paper, so would you please graph this right here? f of x equals 2x. Okay. You should know what that looks like. It is a line. Y-intercept of what? 0. Okay, so we got a 0. So go here. Now what? Yeah, the slope is 2 over 1. So we go up 2 over 1 here, up 2 over 1. Right? See it going? Now you have an interval of what? 0 to 4. 0, 1, 2, got it, 3, got it, 4. Okay, so the boundary is here. But if you keep this line going, you're going to end up where? Up 2 over 1. That'd be 6. Where are you going to end up, guys? At 4? You're going to end up here at 8, aren't you? Okay, so this is 4 comma 8, 3 comma 6, 2 comma 4, 1 comma 2. Okay, so now what do I want? I want the area under the graph. But you're bounded by the what?
Inter.
The boundary on the bottom is what? X-axis. You're also bounded by an interval. What interval? 0 to what? 4. So be here. Here's 0. Here's 4. And you're bounded by the function f of x. Well, that's right here. Okay, so I'm asking you to find the area of a what? Triangle. So you're going to say 1/2 times the base times the height. Half of what? You calling this your base? 4 times what? 8. Look at the y value. The y value is telling you your height. It's 8. So you're going to get what? Half of 32? 16 square units. Good? Confusing at all or what?
Nope.
Why?
Because we've done all of it.
It's a triangle. That's why. How many of these are on the test?
0.
0. Let's keep going. All right. So now, this one just talks to you about what are we going to do when it's not a line? It might be a curve. What are we going to do? In calculus, we begin by approximating the area. So when you start doing this in calculus, they don't just tell you how to do it. They say, let's approximate the area under any curve by dividing the region into a series of rectangles of equal width. Okay, so here's what I'm going to do. I'm going to say, if this is 0, because it kind of looks like 0, let's make up a number like, we'll go 8. Let's go 8. So if your interval is 0 to 8, we want to break it up into a series of what? Rectangles of equal width. Okay, but you got to have intervals that make sense. So let's break it into four rectangles, okay? So I want 4 intervals. What would I be going by? 2. 8 divided by 4 is 2, so you're going by 2. 2, 4, 6, 8. Okay?
Yeah.
Now you need to do this. You need to make a series of rectangles. Okay? Now with these two numbers, you can either do left endpoints, okay? Or you can do right endpoints, okay? So they're gonna tell you on your assignment today what to do. So let's do right. Okay, let's do right. What does a right endpoint mean? It means this. Pick your first interval, 0 to 2. Which ones are on the right? 2. Start at 2, go up to your function, hit it. Once you hit your function, go back to the 0 and make a rectangle. So there's your first rectangle. Okay, call it rectangle 1. Okay, now the next interval is 2 to 4. We're doing right endpoints. Which one's right? 4 is right. So we go up, we hit the graph right here. We come back to 2, like that. We make rectangles. This is rectangle 2. 4 to 6, make another rectangle. Pick the right number. The right number is 6. Backwards, back to 4, rectangle 3. Next one, 6 to 8, pick the right number, 8. hit the graph, come back, down to 6, rectangle what? 4.
Oh.
See, I have no formula for you to get the area under the curve. So what we're gonna do is make a bunch of rectangles, and we're gonna estimate the area. Now, is this gonna over or underestimate? Yeah, this is overestimating. This is wasted area. This is not true. This is not under the curve. This is overestimating. So to get the answer to this, you take all the areas of the rectangles and do what to them? Add them up, yeah. R1, R2, R3, R4, add them up. Okay? And you get the area, right? Not in this class. In calculus, they will get you to that point, okay? All right, I'm just introducing the area under a curve known as the integral, okay? Now this is overestimating because I went above the graph and came down. There's underestimating. When would I underestimate? Left hand points, okay. So keep going. By the way, that's all I wanted you to do. Just draw me some right end points, okay? Next, let's do this one. It says, now take that same graph and do how many equal widths? 8 equal widths, or what they call subintervals, okay? And do a what endpoint? A left endpoint at each of each as the height to form rectangles. Okay, so here's 8. Now, if I'm going to do 8 subintervals, each rectangle will be how what's the width? 1, 2, 3, 4, 5. Okay. 6, 7, 8. Okay. Now your job is to do a left endpoint. So pick the number on the left. Between 0 and 1, what's the number? 0. Go up to the function. By the way, I'm on the function, right? Right? I'm on it, so now I go back to the other number and I go right down to 1. Well, where's the rectangle? Did I form a rectangle?
No.
No. Okay. Now between 1 and 2, pick the left points, left numbers. Go up to the function, hit it, come over, down to 2. Do you see it? That's actually your first rectangle. Okay. 2 and 3, hit it, over, down. R what? 2. 3 and 4, pick 3, hit it, come down to 4. R what? 3. As I keep going, how many rectangles do I form? Yeah, this would be rectangle 7. Question is, why are there only 7 when they said 8 equal widths? The first one did not create a rectangle. So is this all wasted space here?
Yeah.
Yeah, it's all wasted. This is a waste. And are you under or overestimating your answer?
You are underestimating.
Yep. But look at how much wasted space in the first one. Less wasted, less.
I like that you get quieter.
Okay, yeah.
A little less.
So you have the same amount of wasted space in both of them? So like if you add...
It's good. It's a good question. I would say this to you. I believe so.
Walked right into that.
I don't want to say for sure, but do you know what she's asking me? If you go back to the other one, did the other one have 8? Oh, then it would be.
But if you were to do
Yeah.
the right side.
So Maddie is saying this. If I did a right, guys, watch this. If I did a right out of 2 and 3, 3 is the right. Hit it, over, down. Now I'm overestimating. Is this and this the same?
No.
It's probably not the same, but Maddie, so close.
But like you have that more wasted space in the first one.
Right. But what I'm saying is, I don't think it's exactly the same, but you're going to get a question on your worksheet that's going to ask you something about that, and I don't want to give it away. Okay, not yet. Are you guys okay? Okay. All right. This one says the same thing, except it does the right. Do you see this? Pick 1, go up, hit it, come over, and down. So now, how many rectangles do you get on this one? Yeah. you are going to get 8. Okay, so hang on. This is going to cause you some headaches because you're not going to go like you're going to say, why am I getting 7? Why am I getting 8? You got to understand when you did the other one, this one, you did the left endpoint, hit the graph, came over to the other one, and you came down, but there's nothing for it. So sometimes you won't get a rectangle, and sometimes you will. This one you don't, so you only get 7 rectangles. This one you got how many? 8. This is why you'll get some of them wrong if you get them wrong, okay? Whew. All right, here we go. Here are all the directions on how to do it. I'm not going to read them to you because if I just read them to you, you'll get kind of confused and you'll go, what's he saying? Let's just go do a problem, then come back and read these next. So here's the problem I want you to do. Take that function, f of x equals what? 2x plus 1. And they already graphed it for you, right? All right, I'm going to do this. F of x equals 2x plus 1. And let's do this problem with what? Left. A left endpoint problem. Okay, what are your boundaries here? X-axis, always. The function, right here. Okay, and then they did try to show you this from what to what? 0 to 4, so this is 1, 2, 3, 4. You have 4 triangles. I said triangles. You have 4 rectangles, okay? We're going to do left endpoints. So pick which one, 0 or 1? 0. Hit the function right there. Come over to 1. Create yourself a triangle. There it is. Are you underestimating or over? This is under. This is not the right answer. It's lower than the right answer. Pick the left endpoint. 1 or 2? 1. Go hit it. Come over to 2. Come down. 2 and 3. Pick the left endpoint. 2. Go up. Hit the function right here. Down to 3. Sorry, this is supposed to be butted up right there. Okay. Pick 3 and 4. Which one? 3 or 4? 3 is the left. Go hit the graph. Up about right here. Come over to 8. Come down to 8. Okay. Now, when you do these problems, you have to do this. Ready? See these points? You have to tell yourself the ordered pair. So this ordered pair would be 0, comma, 1. Did you put it in 2 times 0 plus 1, or did you just look at the graph? Probably looked at the graph. Okay, what about 1? This point is 1, comma what? 3. Either you look at the graph or you just put the 1 in. 2 times 1, 2, plus 1, 3. All right, this point. 3 what? 3, 5, this point. Oh, did I mess up?
Yeah.
I messed up, sorry. 3 what?
7.
7. This one is 2,
2,
5.
5.
Okay. 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 All right. This is 2, 5. All right. Now, you know you're going to estimate the area by adding rectangle 1, rectangle 2, 3, 4. Okay, so here we go. First rectangle plus second rectangle plus third plus fourth. Okay, every rectangle has length and width. Here we go. What's the width right here?
1.
What's the height?
1.
And you know that because of the y value.
Right.
One is 1. Next one. Width,
1.
height,
3.
3. 1 times 3. Next one. Width is 1. Height is
5.
5. Width is 1. Height is what?
7.
7. Okay. And really the ones, you didn't even need to write them.
It's 16.
It's what?
16.
9, 16, 16 unit square. Is this exactly right or approximately?
That's a little less.
Well, what?
Okay.
I've never understood the difference between exact and approximate.
Well, there's see.
Exact means it's exact. Approximate means it's just about right, Paul.
Okay,
That's it.
that's what I wanted to know.
Could you find the
What?
if you were to do like a triangle from
Please
like
listen.
4 to 9 and then go over and then find the rectangle and then subtract a triangle from it? Is that like exact or is that not?
Well, if you wanted the exact on this, you could probably. What did you want to do?
Like take the area of the triangle.
Oh, this from here to here.
The tiny triangle. The tiny triangle.
Yeah.
Well,
This
like no, like 0 to 4.
Yep.
Is like one side.
Yep.
And then 4 to 9 is the other side of the rectangle, and then you cross it over. So like, never mind. It doesn't make
Right here.
Yeah.
4 to 9.
And then you just subtract the tiny triangle.
No, then like the triangle on the top, you find the area of that and subtract it from the rectangle.
Yeah.
But that's like exact.
Here's
It's not-
like-
I'm not looking for exact right now.
Yeah.
You know why you guys are probably struggling with this because you're kind of going, wait a minute, I can get much better than this. I'm just trying to show you when it's a curve. When it's a curve, we're gonna do rectangles because rectangles is the best we can do. This one, we could get a lot better answer, but we're just using rectangles to approximate the answer.
Could get the exact.
You could,
Yeah.
you could, but we're not going to right now. This is just too easy.
Too
easy.
It's just too easy.
Move on. Here we go. This is where it gets harder. It'll get harder. Here's your function right here. Y equals square root of x plus 1. Okay? Using how many equal subintervals? 4 subintervals. Okay? And what kind of endpoints? Right endpoints. You got to know what endpoints they're talking about. As heights. Find the approximate area under the curve from what? 0 to 2. Okay, so here's 0. Make this big. Make it big. 0 to 2. Okay. Since how many subintervals are we going to have? 4. You take your interval, which is how long? From here to here. 2. So take 2, divide it into 4 equal parts. Each interval will be what? 1/2. Okay. So you're counting by halves. Okay? So that's how you break your x-axis up. You just divide the total length of the interval by the number of subintervals you want. I want 4, I divide by 4. If I want 8, I divide by 8.
Will they give you that number?
Yeah, they always do. Okay, Paul? Okay, now, ready? You gotta get your graph. Okay, so let's put 0 in. What's the square root of 0 plus 1?
1.
1. Okay, there it is. You have a point right here. It's 0, comma 1. Okay, now put in a half. What's the square root of 1/2 plus 1? I don't expect you to know that. Type it in. Type it in. Square root of 1/2 or 0.5 plus 1.
No.
Somebody. 1.7. Okay, so here's 2. Kyle said it's about 1.7, so 1/2, comma, 1.7. Okay, what about 1? You can do this one in your head. Square root of 1 plus 1. 2, 1, comma, 2. So you can see the function. It's going like this. Put in 1.5. 2.2. 1.5 goes in. 2.2 comes out. Okay. You have to get these points. Okay. Put in a 2. Put the 2 in, you get 2 goes in. I don't know the answer. 2.4 comes out. Got it. Okay. And this graph, it just continues forever, but we don't care about it because we have intervals from what? 0 to 2. So we have to quit right there at 2. And then we quit at 0. So really, this is the area we're trying to find right here. Okay. All right. What's the area under the curve between 0 and 2 in the x-axis? Well, are we doing right or left? We're doing right. So pick the number on the right. It'd be 1/2. Go hit your graph. Well, let me go a different color. Go hit your graph. Come over right here, and then come down. This is rectangle 1. Pick your right number. Is it 1/2 or 1? It's 1. Go hit your graph. Come over. Come down to 1/2. You can see already this is a over or underestimated answer.
Over.
Over. You're going way too far over the function. Pick 1.5, hit the graph, come over, go down to 1. This is rectangle 2, this is rectangle 3, this is rectangle 4. In rectangle 4, you'd pick the number 2, you'd hit your graph, you'd come over and down. And I hope you can see, as your function starts to flatten out, there's less and less wasted space. So really, the one triangle that had the most wasted space is the first one, right? Okay, help me get this right. All right, so here we go. Rectangle 1. What's the area?
0.5.
Half times what? 1/2 times what? Look right here. 1.7 is the height, right there. Plus rectangle 2, half times what? What's the height? 2 plus rectangle 3, the width is 1/2, height is what?
2.2.
2.2. Okay, width is what here? 1/2 again. What's the height? 2.4. That's why you guys need those points. You need your ordered pairs to tell you the height of the rectangle. Okay, this is nothing but you typing it in. Paul, what's the answer?
I don't have a calculator on me.
Hunter, what's the answer? The answer is, go get a calculator. Morgan, what's the answer?
Working on it.
Working on it. 4.15. Okay, good. 4.15 square units is the answer. Is this a little higher than the actual answer or a little lower?
A little higher. A little
It's
higher.
overestimate, right? Okay. Hey guys, take a peek. Ready? Look at this. Could you have done this with your calculator? Are you watching? You see every one of these multiplication problems? They all have what in them? 1/2. Could you have factored out the 1/2? Could you have just done this? Okay. And then these spots, you'd have what? 1.7 plus 2 plus this plus this. Get an answer. And whatever. I don't know what the answer. Oh, it's supposed to be 8.3. And then you take half of 8.3 to get that. You can speed yourself up a little bit. If you have a common factor, take it out.
You will have a common factor.
Yeah, you should. Because the width will never change, right? Okay. Okay. All good? Okay. Oh, skip that slide, go to that slide. Oh, no. Is that right, guys? Is that our last one?
Yeah.
Oh, okay. Then we're done with the rectangles. You know what to do. But now we're moving to what? Trapezoids. Now, the question becomes, can we do better than rectangles? Are rectangles the best we can do? And the answer is no, because look at this. If you start doing rectangles, what happens is you tend to have a little too much wasted space. That's overestimating by way too much. So what we're going to do on our last problem is use a trapezoid. So here's what I need you to do. We're going to break this interval 0 to 4. 0 to 4. Here's your function, right? Here's the x-axis. Let's break it into 4 equal parts, which means you're counting by what? Ones. Okay. And now let's go make trapezoids instead of rectangles. You'll see why this works better. So from 1, go hit your graph. From 0, go hit your graph. Okay. Now to draw a trapezoid, this is the one side, this is the other. How much wasted space do I have now? Just a tiny bit. Trapezoids actually do a better job estimating the area. Okay, where are my 2 parallel sides now? Verticals or horizontals?
Vertical.
Okay, so this is base 1, this is base 2, correct? Okay, so here I go, I'll draw my next one. Here, here. 3 goes here, here. And the weird thing about trapezoid 4 is it really doesn't form a trapezoid. You'll see in a second. Will you please give me some points now? Ready? This point. What's this point right here? 0, 4. Okay. And you would know that if you just put 0 in. What's this point going to be? 1.
1.
1 comma square root of 15. Put the 1 in, you'll get square root of 15. 2 goes in, what do you get? Square root of 12. 3 goes in, you get what? No. Try it again. 3 goes in. 3 squared.
Square root of
9.
7.
16 minus 9 is 7. Okay, square root of 7. Okay. Okay, here's the weird one. Put a 4 in. What does 4 get you?
0.
It does get you 0 if you put a 4 in. Now, this is why it's that 4th one's weird, because when you draw it, here's what happens. You go from here to here, back to here. So what is this? It's a triangle. So it's trapezoid, trapezoid, trapezoid plus triangle. Okay? So here we go. Trapezoid 1, trapezoid 2, trapezoid 3, and triangle. Okay?
Oh.
All right, here we go. Trapezoid 1. Oops. Okay, trapezoid 1 goes like this. Half of the base is added. What are the bases here? This is one base plus another base.
Right.
4 plus the square root of 15.
Square root of 15, gotcha. What's the height? Okay, the height creates a right triangle with the bases. It's got to be this, right? It's got to be 1. Which is a waste of time, by the way, but I'll put it anyways. Plus, trapezoid 2 is going to be 1/2. The base is added times 1.
Square root of 15.
Square root of 15 what?
Square root of 12.
Plus,
Square root of 1/2.
square root of 1/2 times square root of
Square root of
12
12. Square root of 7.
plus square root of 7 times 1
Times 1.
plus the triangle. Half of the base. What do you want to call your base? This side? Okay, so that's 1 times the height.
3.
Square root of 7. Okay. Wouldn't this add up to just about the correct area? It's going to be a little wasted. Like we're missing it by a little bit. We're under the right answer. Again, if you guys look at it, is there a common factor?
1/2.
Yeah, we could have just taken out the 1/2. And then inside you'd probably go what? 4 plus square root of 15 first, plus square root of 15 plus 12, square root of 12 second, plus square root of 12 plus square root of 7, plus, what's the last one? Just square root of 7, yeah. Get the answer to that, cut it in half, and you're done. I mean, you could do it this way, or you could just type it all in. Anybody got any of this? Final answer, or maybe this answer right here? I don't know. It's funny how some of you just wait for others to do your work. Take a calculator. Actually try to get this
Yeah,
answer.
guys.
Just because somebody tells me the answer doesn't mean you know how to get it.
Ouch. Oh, I'm getting close, Painter.
6.3 for
Almost
what?
there. Don't repeat it.
The whole answer is 6.3. I don't remember that being the answer. This one? 9.2. I don't remember.
I got
that.
23.97
For this or this?
for that
23 what?
0.97.
Okay, that's what I remember being. But then that's not the answer.
But they multiply it by
Half of 23.
1 half. Oh,
Probably 11 something. 9.8.
okay. Way still my thunder. 11.98.
That's it. Okay. Now is that under the right answer or just a little above the right answer?
Just a little below. It's a little under.
Little
Little
'cause
under.
We underestimated. We were. If you look,
Don't
we did
underestimate.
not account for this little tiny area up here, here, here. Okay.
I'm not.
You don't have to say that. I'm just trying to get that in your head. Sometimes it's under, sometimes it's over. Okay. Okay. 1 through 6. Cross out 5. 1 through 6. Cross out what?
5.
Okay. You guys have 5 minutes.
Cross
I
it
think you can get number 1 done. I think.
That's all.
I need the charger from Cole.
No, I'm not going to take today's homework. Guys, can we talk about the review tomorrow? Yeah, 12-3 I'll take. I think, Grace, did you need 12-3?
Oh no!
Okay. Did you need 12-3? Okay. I can take 12-3 guys if you have.
This day. I got 12-2 for you.
Okay, just 12-3.
Very funny joke.
12-3 minutes.
Damn boy.
You had to predict anything about
Okay, guys, I asked you to do number 1, get 5 minutes, go. We got a solid 5, maybe even 6. Go. Paul, Will,
I'm getting you your
What's up?
math.
prove to yourself you can get this right. We
drawing
cancel.
rectangles using left and
Cancel. So then you're in your calendar, we're right on schedule. We did a review. So now we're reviewing for the test. Come back tomorrow, and I might partner quiz you, I might just plain and simple quiz you, I don't know. I don't know. But tomorrow's gonna be some kind of quiz. So have your review done tomorrow. This worksheet, I probably won't even look at this worksheet till Monday.
And that's it.
I gave you the same graph twice. So on the one on the left, do left endpoints. The graph on the right, do right endpoints. It's the same graph. You'll get different answers. But I'm saying, I gave you the same graph twice. So you can do left endpoints and right endpoints.
If it's not curved, can we do like a rectangle or a trapezoid?
No, stick with rectangles.
Like there.
It says rectangles.
Is it the same graph?
It's the same graph I gave.
Don't think so. Like when you do left endpoint and when you do right endpoint,
Yep.
are they the same? They
No,
don't look-
one of them overestimates, one of them underestimates.
Yeah, but
So they're not gonna be the same answer.
But the
The,
point
the
is,
function's the same,
yeah,
but
It's not a
you are
function.
overestimating on one and underestimating on another. Have you read the question?
What?
Read it. Read the question.
Ha ha.
Oh, that's it. Oh, so you just use the app.
Two? I would say 2.
Yeah, can't you read it? Can't you just visually see the points? Yeah. You don't have to do any calculating, just read the points. You get it?
maybe. So Paul's having it now, but like, this one you're overestimating,
Yep,
right?
this one's
But this has got one less rectangle.
No.
Cause
This one has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You got 5.
okay, cause on this one I have one more.
And where'd you get 6? I count 5.
Yeah.
One,
So
two,
You shouldn't have this
3, 4, 5.
9. This one isn't forming, right? For left end point.
Yeah, you're left. So you, this
That'd
is
be
this
over
is
if
your
you
height.
went up. and
Oh,
go
you were
over.
doing another one over here without even knowing.
no, that's right. So
What'd you get on the left?
54.
Yes, you're right, Will.
Job well.
Okay. I kind of want you to leave knowing you got them right.
oh, it's
So I know you're not done.
Yeah.
60 what?
Six.
Okay, the right end point
this is
overestimates the area. A little too big, a little too small here. Then the question said, if you read the question,
What?
using your answers from these two products, what would be the reasonable estimate?
60.
Why?
Because you add them together and then divide them both by 2.
What's that word?
Average.
Mean.
So a really good estimate would be 60, right? Okay. But I was looking for 54 on the left and 66 on the right. Okay.
Paul, I'll
Alright.
get the trophy.
Oh, hey,
Alright.
what number can you cancel?
5.
5. Don't do it. We never did it in our notes. 5. Don't do it. No, it's a book review.
Oh.
Yes, it's a review.
Practice this tomorrow, guys. Get ready for it.
Way readier than you will ever be.
You're not even.